Hi everyone. Today we're going to talk about self-cleaning materials. First, I'm going to talk about how it started, the discovery of the Lotus effect by Wilhelm Bartholdt of the University of Bonn in Germany. The story of self-cleaning materials begins in the nature with the sacred lotus. It is a plant that grows in muddy water, but its leaves, standing meters above the water, seem like they are never dirty. And rainwater washes dirt from that leaf easier than any other plant. It is this property that drew Bartholdt's attention. In the 1970s, when he began to think about the possibility to scan the lotus leaf under the electron microscope, Bartholdt noticed that the lotus never seemed to need washing, because usually at that scale of magnification, specks of dirt can ruin the picture, and so the samples have to be cleaned. But the lotus doesn't have this problem. Next, I'm going to talk about the lotus effect. Bartholdt realized that the effect is caused by the combination of two features of the leaf surface, its waxiness and the microscopic bumps. He knew from basics physics that the waxiness alone should make the leaves hydrophobic, or water-hating. On such materials, drops of water sit up high to minimize their area of contact with the material. Water on a more hydrophilic or water-loving substance, on the other hand, allows the water to press across it to maximize the contact area. For a hydrophilic surface, the contact angle where the droplet surface meets the material is less than 30 degrees. A hydrophobic surface has a contact angle greater than 90 degrees. In addition, he understood that the innumerable bumps take things a step further and causes the lotus surface to be super hydrophobic. The contact angle exceeds 150 degrees, as you can see on the picture, and water on it forms nearly spherical droplets with very little surface contact that roll across it as easily as ball bearings would. The water sits on top of the bumps like a person lying on a bed of nails. Air trapped between the water and the leaf surface in the spaces around the bumps increases the contact angle, which is an effect that is described by the Casey-Baxter equation, named after A.B.D. Casey and S. Baxter, who first developed it in the 1940s. Apart from Bartholdt, there are also people that also set their sight on no need to clean technology. Take Japan, for example. People have developed self-deordinizing and disinfecting surfaces for bathrooms and hospitals. And also Michael Rubner and Robert Cohen of the MIT have thought about keeping bathroom mirrors unfogged and controlling microfluidic labs on a chip, in which fluids move through microscopic pathways. Next, I'm going to talk about the motivation of the applications. First is the realization. If rough waxy surfaces could be synthesized, an artificial lotus effect could have many applications. And there comes the honey spoon, which is a homemade microscopically rough silicone surface that allows honey to roll off, leaving none behind, which is a thing that Bartholdt invented and convinced some large chemical companies that the technique was viable. And this is also rated one of the 50 most significant German inventions of recent years, which is the Lotus effect. And these are the reasons that there are many applications appear in the future.